Find the magnitude and the direction of the resultant of the following forces given in the diagram. So here we've got an XY plane, and we have a force going in this direction, 2 newtons. This force here is 6 newtons at 60 degrees to this axis. This force here, 4 newtons at 30 degrees to this axis here. And finally a force, 5 newtons at 45 degrees to this axis here. If we draw using vectors, so I is a unit vector in the x direction, j is a unit vector in the y direction, and now if we label the origin as 0, label this one A, B, C, D. Now these can actually be represented by a single force, and we need to find the resultant vectors. Using vectors. So if we take the first force, which is this one here, which is just coloured in red, and draw it down here, OA, 2 newtons, and then take this one here, OB, and join it to A, which is 6 newtons, and then take this one here and join it to B, which is 4 newtons, and then take this one here and join it to C. The resultant force of all these forces in these directions will be the same as doing OD, and the angle will be, the direction of that force will be at theta to the positive x-axis. So the resultant is the same as find the magnitude of OD. So first of all we've got to find the vector OD. Now vector OD can be found by doing OA plus AB plus BC plus CD. So the first one's quite simple because it's 2 along and 0 in that direction. However, this one we've got to split it into its components. So this direction will be 6 cos 60, and this one will be 6 sine 60. So you need to know your trigonometry to do this. For this particular force here, this one will be minus 4 cos 30. It's minus because we're in the negative part of the axis, but this one here will be positive, so it's 4 sine 30. And for the last one, this one will be minus 5 cos 45, and this one will be minus 5 sine. So going over to the page, just drawing that diagram out again and drawing out this again. So using your trig ratios, which you should have learned at higher level maths or standard level, this becomes 6 cos 60, so 6 times a half, minus 4 times root 3 over 2, minus 5 times root 2 over 2, that's cos of 45, 0, plus 6 sine 60, so 6 root 3 over 2, plus 4 times sine of 30, which is a half, minus 5 times root 2 over 2. Simplifying that, so this becomes 2 plus 3, which is 5, minus 2 root 3, minus 5 root 2 over 2. Here we're going to get 3 root 3, plus 2, minus 5 root 2 over 2. And then we'll have to take our calculator out. So working them out to a few more places than we actually need in the question. So when we work this out, we get minus 1.9996, and when we work this one out, we get 2.8660. Now we expected here this to be in the negative direction, so it's come out to be negative, and this to be in the positive direction, it's come out to be positive. We need to find the magnitude of this vector to give us the length of that vector. So magnitude of OD is the square root of minus 1.9996 squared plus 2.8666 squared. So on my calculator that gives me 3.4925. So the resultant force is going to be 3.49 newtons. Now what we need to do is find this angle here. So just drawing this a little bit out. So there's OD, making a right angle triangle and making this angle here, this one being alpha. This length here is 1.9996. We don't need to worry about being minus, we only need to find the value of alpha. And this one here will be 2.8660. we know the length here is 3.49 newtons. So these are the components of that force. So using a bit of trigonometry, alpha will be tan to the minus 1 of opposite over adjacent. So it's tan to the minus 1 of 2.8660 divided by 1.996, which on my calculator in degree mode will give me 55.1 degrees. And therefore theta will be 180 minus 55.1, which gives me 124.9 degrees. So the resultant force is 3.49 newtons at an angle of 1.24.9 above the direction of I. Okay, so this shows you how you use a practical use of vectors and trigonometry to find the resultant force at a particular point.